Okay, hello everyone. My name is Michael Downing, Library and Information Services Coordinator at the AWRI, and it's my pleasure to welcome you to today's webinar and also to welcome today's presenter, Dr. Rachel Kilmister from the Department of Economic Development, Jobs, Transport and Resources. Rachel has a long history in grape and wine research and is with us today to discuss a field project examining the effect of rising temperature and CO2 levels on grapevine physiology and grape and wine composition. Now, before I go over to Rachel to tell us more about the topic, a couple of notes on what you as the audience can expect from the webinar. As usual, the format is a short PowerPoint style presentation, and this is followed by a Q&A. The session is being recorded and will be available to view via the AWRI website. And for those that are new to webinars, it's important to remember that webinars are interactive and that there are a number of ways that you can get involved. Now, to ask a question, please type into the question section of your control panel in the bottom right corner of your screen. For those with access to a microphone, there's also the option of speaking directly with our presenter by clicking the raise hand button. This is located in the top left section of your control panel. If you'd prefer to ask a question via email, please do so at infoservices@awri.com.au. Feel free to send through your questions at any time, and once we get to the Q&A, I'll get as many questions through to Rachel as possible. And finally, for anyone that would like to get involved through Twitter, please use the Twitter handle @_AWRI. Okay, that's enough from me. I'm now going to hand over to Rachel to get us started.
Okay, hi everyone. Thanks for listening in today. I'm going to be talking about a trial we've got running up in Mildura that looks at the impact of elevated carbon dioxide and elevated temperature and grape and wine production. We've had this trial established in 2013, so we've had two full seasons worth looking at the impact and with treatments for elevated temperature and carbon dioxide. And today I'm just going to give you a bit of an overview of some of the results from the last two seasons that we've been doing in terms of the grape and wine production side of things. So you're probably all familiar with climate change and what's happening out there, and firstly, there's two different aspects of climate change that we're interested in, and the first is that there's rising temperature. So over the last 100 years, you can see on the left we've got a graph tracking the global temperature over the last 100 years, and you can see especially in the last 40 years since 1960 there's been quite a dramatic increase. So we're seeing about a 0.1 degree increase each decade, and in another 30 years we're probably expecting that temperature to be increased by about another 2 degrees Celsius. And that temperature change is mainly driven by the increase in carbon dioxide concentration in the atmosphere. So on the right there you can see that the increase in carbon dioxide level has been going since the data that we've got here, it's been increasing steadily since 1960, and the current concentration level is about 400 ppm, and in another 30 years we expect that to be around about 650 ppm. So in terms of grape and wine production, and you're probably already seeing an effect from temperature and probably already trying to manage that from an industry perspective, and the focus so far on the research really has been on that increasing temperature and hasn't really looked so much at the carbon dioxide. So there have been some trials out there looking at temperature and carbon dioxide separately to look at the impact of the individual temperature and carbon dioxide, but not the interactive effect. So for temperature, what we've basically been seeing is through historical data and through other trials such as what Victor Sadras has been doing in Nuripta, we've been seeing that we are getting earlier harvest dates based on increasing temperature. So here from anecdotal evidence and from looking through historical data, we can see that as we increase the temperature by every degree, we are getting about a earlier harvest date by around 5 or 6 days for every increase in by 1 degree. And so potentially in another 30, that could mean earlier harvest dates by around about 2 weeks. So from historical data and anecdotal evidence, we're also seeing that the data suggests that there's an impact on grape and wine quality as well. So that could mean a decrease in yield, which may not impact on quality, but certainly may impact on the value of crops, decrease in things like colour compounds, which are very important for red wine quality, things like decrease in total acidity and other astringent compounds like tannins, and decrease in volatile aromas and increase in pH. So a lot of these factors are very detrimental effects on quality in terms of what the effective temperature is going to have on grape and wine production. So there has been a trial done in viticulture out in the field on mature vines in Italy, where they've increased the carbon dioxide concentration around grapevines to see what impact that would have on grape and wine production. So just carbon dioxide on its own actually has the opposite effect of what temperature has on many aspects. So on the top there's 2 graphs over 2 years that shows basically the plant growth over 2 seasons, and you can see there the 2 higher lines there with the 2 increased levels of carbon dioxide concentration. We see greater plant growth across both seasons, and this translates also into a higher yield that we're seeing for vines grown under increased carbon dioxide concentration, and this is actually opposite to what we saw from temperature effects. So when we look at grape quality compounds that are grown under increased carbon dioxide, we also see an opposite effect to temperature. Here we have our ambient temperature grapes grown and the total anthocyanin levels, or sorry, this is in wine made from grapes grown under elevated carbon dioxide levels. We have our ambient temperature concentrations are much lower than the concentrations of total anthocyanins grown under elevated carbon dioxide, and here we also have the non-anthocyanin flavonoids such as tannins are also at increased levels when grown under elevated carbon dioxide, and once again this is an opposite effect to what we saw with temperature. So because we are seeing an opposite effect from temperature and carbon dioxide, what our trial is about is trying to look at the interaction between the temperature and the carbon dioxide to see if there's a compounding effect for CO2, and also just to demonstrate and try to determine whether the advancing maturity is actually from increasing temperature and what effect does the carbon dioxide levels have on it. So the trial that we have set up is basically set up in a patch of Shiraz that we have up in Mildura. To do it, we have open top chambers. We have 16 of those placed in a random block design throughout our Shiraz block. So you can see the chambers there. We have 16 of them, and within that vineyard there are 16 chambers with 4 different treatments and replicated 4 times. So you can see from this picture that it's not a trivial exercise. It's quite a substantial infrastructure to get this trial up and running. We have to plumb in carbon dioxide. We have a big tank installed outside of the vineyard to plumb CO2 in. We have to have infrastructure for active heating from heaters to actually heat up inside the chambers as well. So for the treatments that we have essentially 4 treatments. So we have a control. So first we have a control outside of a chamber. So it's just our vines we use as a reference point, so they're grown under just standard viticultural practices without a chamber. But then to test the effect of the chamber, because we may have some effect from light and from wind, we have a chambered control. So we have our chambered control, and then we also have a treatment, which is the elevated temperature on its own. Then we have an elevated carbon dioxide on its own, and then we have the combined effect of temperature and carbon dioxide. So what we found is that there is a chamber effect, so we do see a slight difference in our results based on having the chamber around the vines. So from here on in, whenever I talk about the control, we're just using the control chamber there as our reference point for all the other treatments. So here we have a picture of inside our chambers and how we actually heat and elevate the carbon dioxide level. So we have here fan heaters for increasing the temperature underneath our vines, and they pump out warm air underneath the vines to fill the chamber, and the aim is to increase the temperature of the chamber above the ambient air by about 2 degrees Celsius. So here on the right you can see the temperature of our chamber over 24 hours, and so here we have our ambient air and our control temperature, and above that we can see that we're pretty consistently increasing the temperature of our elevated temperature treatments by around about 2 degrees throughout the 24 hours of the day, and that increase in temperature is continued throughout every day, every week, throughout the whole entire year. And we're aiming for about 2 degrees Celsius, which is about the predicted increase in temperature that we'll see in about 2050. So for our carbon dioxide levels, we have a big tank outside the vineyard which plumbs carbon dioxide into this manifold, which is placed around the central part of the vine. And so we don't actually turn the carbon dioxide on at night time, as the plants aren't photosynthesizing. It saves on some costs there. But then during the day, we're aiming for about a 250 ppm concentration increase from what the ambient concentration is. So here on the right, you can see that we consistently get about a concentration of just above 600 ppm in our carbon dioxide treated chambers. So for the rest of the presentation, I'm just going to give you a brief overview of the results that we've had from our first 2 seasons, which we started in 2013-14, and we've just had our second season in 2014-15. So the measures that we're taking to have a look at what the impact of elevated temperature and carbon dioxide are on our grape and wine production, we're looking at measuring phenology, or describing phenology. We're also looking at the physiology aspects in terms of how the grapevine is responding and utilising the extra carbon dioxide in the air. We're then assessing the grape and wine quality parameters by looking at grape composition and wine composition, and also doing sensory on the wines that we make. The wines are made from small-scale winemaking on our experimental winery here on site in Mildura. So first I'm just going to talk about the phenology. So basically from the 2 seasons of phenology, we're seeing that the temperature is the main effect on phenology. So it's a pretty similar effect to what we've seen previously in other trials, and from the anecdotal evidence we're seeing earlier maturity and earlier phenological milestones. So here I'm just going to present the 2014-15 data, and I've just got a photographic representation for this purpose today. So here we have pictures from 4 different dates across bud burst. It's a little bit difficult to see when the buds are bursting from a photo, but you can see here in our last photo date that basically just when you're getting bud bursts in our control down the bottom here, we've already got quite substantial shoot growth happening in both of our elevated temperature treatments up the top. And that's even when we've got a carbon dioxide treatment. So heat is the main impact on earlier bud burst for our treated vines. So for flowering, we also see earlier flowering for our treatments where we have elevated temperature. So once again here you can see just as the vines are still flowering in our controls, we've got fruit set already in our elevated temperature treatments, and in this final point here, just as we have fruit set in our control, the berries are well and truly formed and growing in our elevated temperature treatments. So for veraison, a similar pattern. We're seeing earlier veraison happening in our elevated temperature treatments. We're starting to get colour here in our elevated temperature, but we still have green berries in our control and in our carbon dioxide only treatment. And then here in our elevated temperature, once we've got full colouring in our elevated temperature treatments, we've still got green berries happening in our controls. So this is actually a graphical presentation of the pictures that we've just seen for veraison. So what we're actually seeing is as veraison starts, it might only be a couple of days difference in when the actual colouring begins in the treatments, but we're actually seeing a more compact colouring in our elevated temperature treatments. So the actual rate of the colouring is much quicker in our elevated temperature and reaches full colouring before the controls and elevated carbon dioxide treatments. And we see a similar pattern happening with our flowering as well. So the effective temperature that we're seeing in our phenological milestones of flowering of veraison carries through to harvest. So basically we're getting earlier maturity with our elevated temperature treatments, and in 2013-14, the first season, we were harvesting our elevated temperature treatments basically more than 10 days earlier than our controls and elevated carbon dioxide treatments, and there was only a couple of days difference between elevated carbon dioxide and control in the first year. In the second year, we still saw our elevated temperature treatments harvested before our controls by more than 10 days, but we're actually seeing earlier harvest date with our elevated carbon dioxide. So at this point in time, with only 2 seasons, we're not sure whether this is a seasonal effect or a direct impact of the carbon dioxide and the vines acclimatizing. So one of the important things to remember with only 2 seasons worth of data is that in the first season, basically a lot of the parameters that we're measuring are actually laid down in the previous season when the buds are formed in 2012. So in 2012 we hadn't applied any treatments yet. So essentially a lot of this effect is only from temperature because the carbon dioxide treatments hadn't been applied to those buds that are formed. And now in the second season, the carbon dioxide effect is actually in full effect for buds that were formed in this season. So essentially we need another couple of seasons, we're going to be analysing for another couple of seasons to actually see what that year-on-year impact of carbon dioxide effect is. So we want to see whether this is actually a not a seasonal effect but is an actual real effect from carbon dioxide, and see what that will be year on year on. So I'm just going to talk briefly about some physiology data that we've got. I'm just going to put a disclaimer in straight up. Physiology isn't my specific area, and the physiology work that we have been doing on our trials has been done by Everard Edwards at the CSIRO. So in terms of the photosynthetic rate of our vines at the leaf level, what we're seeing is that under elevated carbon dioxide, the vines have increased photosynthetic rate, and we're basically seeing that at the higher concentrations of carbon dioxide, the plant's basically assimilating higher levels of carbon dioxide at the higher concentrations. So what's interesting about these vines is that we would expect that there would be some acclimation. The vines would acclimatise somewhat to increase carbon dioxide, but so far in our data we haven't seen an acclimation of the vines, which means that all the extra carbon dioxide that's being assimilated has to be going somewhere into the vine and being used up. So as we go year on, we're going to be assessing what is actually happening with that extra carbon dioxide. So this year we measured the non-structural carbohydrates in our vines, and what we found was that extra carbon dioxide is translating into higher levels of non-structural carbohydrates in our elevated carbon dioxide treatments. So here we have our elevated carbon dioxide treatment on its own and with elevated temperature as well. So there's an interaction there. What we're seeing is despite elevated temperature, we're still seeing elevated carbohydrate levels with both elevated carbon dioxide and elevated temperature. So what we want to see as we go forward is what is the real impact of what is happening with those extra carbohydrates. What is the vine doing with them? Is it turning into extra plant growth, higher vigour? Is it being put into secondary metabolites like organic acids and tannins and anthocyanins? And what impact is that going to have on plant growth and also on wine quality? And how are we going to have to, and it's important information to find out, because then we can work out how we might need to adapt as we go further forward. So firstly, yield could be one of those areas that the extra carbohydrates are impacting on, and in 2015 we have some of our yield data. So what we saw for our kilograms per vine yield is that under both elevated carbon dioxide treatments, we saw that we had higher yields compared to our ambient temperature treatments. And this higher yield is probably being translated into or from in our elevated temperature treatments, more berries per bunch, and in our just carbon dioxide treatment at ambient temperature, more bunches per vine and bigger berries. So we're already potentially seeing an effect on yield by elevated carbon dioxide, and going forward in more seasons we'll be able to assess that more thoroughly and determine whether the yield effect is real. So another aspect of the physiology is the water use efficiency of the vine. So we've been looking at the leaf stomatal conductance at the leaf level, and so what we're finding is that the leaf stomatal conductance is lower, transpiration is lower under our elevated carbon dioxide treatments, and this makes sense when there's higher concentrations of carbon dioxide. The stomata are closing, and so there's a lower rate of transpiration. But what this means is that there's less water loss, so this translates into better water use efficiency at the leaf level. So under our elevated carbon dioxide treatments, we're seeing better water use efficiency of the vine at the leaf level. So at a whole vine level, this is also translating into more better water use efficiency for our elevated carbon dioxide treatments. So we have sap flow meters out in the for the first 2 seasons. We had sap flow meters. We were able to look at this, and so what we found was that much higher water use for elevated temperature treatments, but that the carbon dioxide water use efficiency was actually compensated for with elevated temperature. So for our grape composition, we've been looking at grape composition for both seasons. So what we found in the first season is that heat was the main effect. So in 2014, we had our grape tannin in our berries was decreased under our elevated temperature treatments. But in the second season, we found that there wasn't a significant difference between any treatments, and there wasn't any difference. So not what we would expect from elevated temperature, and we're not really sure at this point in time whether that's an effect from the carbon dioxide or not until we do more seasons to see whether that is a seasonal effect or it's actually the plants, the vines adapting to elevated carbon dioxide. So we saw a similar effect for our anthocyanin levels in our grapes. We saw a slight decrease in our anthocyanin concentration in grapes in our elevated temperature treatments. And then in the second season, once again we saw a different effect. We actually had slightly higher concentrations of grape anthocyanin in our grapes. So once again, we're not really sure whether that's a seasonal effect or whether we're going to see an effect from carbon dioxide going further forward. In terms of wine, it pretty much translated or followed a similar pattern to what we saw in the grapes. So our wine tannins were decreased in the first season from elevated temperature, and then in our wine tannin in 2015 we actually saw higher levels of tannins when we had elevated temperature and carbon dioxide in combination. For anthocyanin, similar to the tannins, we saw decreased levels in our wines for anthocyanin, similar to the grape levels. And then in 2015, once again, we saw a different effect, and we're not really sure whether that's what's going to happen going forward or whether that's just a seasonal effect. However, there may be some explanation for the differences we saw between two seasons. Firstly, what we saw with the phenological data is that heat had a big impact on both seasons, but we didn't see such a big impact in the second season with our grape composition, and that could be potentially due to the differences in temperature between the two seasons. So here we've just got a pictorial graph of the number of hot days that we have up in Mildura. So with the open circles, you can see over the last 50 years that the open circles represent how many days that occur between December and February above 35 degrees Celsius, and the closed circles represent how many days above 40 degrees between December and February. So you can see since about 1980 we've been getting more hot days above 40 degrees in Mildura, especially in the last decade. So here you can see from the two seasons that we've been conducting this trial, the first season was extremely hot, and the second season, although it seemed like a cooler season, was relatively hot but a lot milder than the season before. So in terms of our grape and wine composition and our anthocyanins and tannins, potentially there might be a tipping point where in a hot season you have a much greater effect from heat, but in a cooler season the effect might not be as great. So lastly, in terms of assessing the wine quality, we are doing wine sensory analysis on the wines that are made from each of the different treatments. So far we've only done 2014. We're about to do our 2015 wines in the next coming month. But from 2014, what we found was that wherever we had an elevated temperature wine, it was significantly different from our control and from our elevated carbon dioxide only treatments. And this pretty much matches up what we saw with the grape composition and the wine composition, where we saw differences in the anthocyanin and the tannin levels, but it's also possible that there's differences in volatile aroma compounds and other flavour compounds as well. So going forward in 2015 and in the next coming seasons, we'll be doing more descriptive analysis and a more volatile analysis of wines so that we can get a better idea of what is causing those differences and what the impact is on quality going forward. So future work for this trial, as I've gone through the data, you can see that at the moment we're not sure whether we're seeing seasonal variability or a real impact from carbon dioxide, and we think that it is a real impact from carbon dioxide that we're seeing, and that with another couple of seasons of assessment we'll be able to assess that year-on-year effect of CO2 and actually see how the vines adapt to that elevated carbon dioxide. So as part of that, we're going to be doing more detailed analysis of some of those different aspects. So we'll be doing more detailed growth analysis and nutrition analysis in terms of trying to determine how the vine is using all of those extra carbohydrates and what's the output from that, whether it's going into vine vigor or using up more nutrients, and what impact that's going to have on grape and wine production, and how we might have to adapt to different strategies to manage for increased vigor or yield or the impact on quality. And so we'll also be doing more detailed analysis of our wines and more descriptive analysis so we can really get a gauge of what the impact is on quality parameters. So the take-home messages for the presentation that I've given today is primarily that we are seeing a heat effect. As anecdotal evidence and previous data shows, we are having earlier, more compact harvests, and that is primarily a heat effect. But we also think that there's a CO2 effect, and that's probably going to be through plant growth, vigor and yield, and potentially going to have an impact on grape and wine metabolites as well, and that will effectively impact on quality. And so basically the next couple of years will provide us with the knowledge of what that impact is going to be and how we can manage for it in terms of viticultural strategies to manage it. So just acknowledge all the people that have been involved in this project while it's been running, and especially Dale Unwin, who's our technical officer on the ground here, and he's responsible for getting the trial up and running and doing all the phenological analysis out in the field every season. And then also Everard Edwards, who's our main collaborator at CSIRO for all his work on the physiology side of things. So that's the end of my presentation.
Thanks very much, Rachel. Rachel's going to stick around for a few minutes to go through a Q&A, so if you've got any questions, please start sending them through now. Just a reminder, if you do want to ask a question, you can type it into the control panel and send through. You can also click the raise hand button if you've got a microphone and want to chat directly with Rachel. There's also the option of sending a question via email at infoservices@awri.com.au. Now I've got one question here already, Rachel. I'm just sending it through to you now. You should be able to see it in your control panel there.
Okay, the question is production of extra carbonyl ions and increased pH. So what we're seeing with pH, I didn't show the data today, but it's variable. So far in the first year we saw I think it was an increase in pH, and in the second year we saw a decrease in pH. So at this point in time, not really sure what's happening with pH, but we'll continue to analyse that over the next couple of years, and if we see some trends, then we can do more detailed analysis of it.
Okay, thanks for your question there, Shane. If you have any follow-ups, send them through now. Don't have any further questions at this stage. Stay on the line for another minute or so and see if any further questions come through. Just got one here now though from Murray. I'm sending it through to you now, Rachel.
Okay, the question is there a humidity change with the increase in carbon dioxide? Now, that's a good question, and I off the top of my head, I'm not entirely sure, but you probably would expect a humidity change, and we are measuring for that. We do have EnviroScans out in our chambers measuring those kind of aspects. I'm just not familiar with it myself. And so I would expect that there would be humidity change, and one of the aspects that would be important going ahead is that effect on diseases and things like that. But at this point in time, I can't say specifically if we are seeing a humidity change without going back and looking at the data.
Okay, thanks Murray for sending through your question there. Thanks Rachel again for answering. Don't have any other questions at this stage, so we'll begin to wrap up. If we get any final questions, I'll get them through to you, Rachel. But before we wrap up, did you want to go through anything before we finish, re-emphasise anything, or are you happy just to finish there?
Yep, no, I'm happy with that. Thank you very much.
Okay. Okay, firstly, I'd just like to thank Rachel for presenting today. Thank you also to everyone who's attended and took part in the session. For attendees, you'll receive a follow-up email with a link to the recording of this session. That email will also contain a link to a survey. Should you need to follow up on anything, please feel free to contact the AWRI directly, and if need be, we can put you in contact with Rachel. Next week's webinar will be presented by winemaker Toby Barlow from St. Hallett, and the topic is juice flotation, a better wine making tool than cold settling. If you haven't registered for this webinar and would like to do so, please visit the AWRI website. And once again, thank you to everyone for joining in, and please check out the AWRI's webinar program to register for future sessions.